So good afternoon and welcome. Thank you for coming to join the conversation this afternoon. I want to give you a little bit of history of how GE started our AddWorks offering and explain to you what actually is AddWorks and why do we think it's important. So just to give you a little bit of context, I'm a design engineer by background, mechanical engineer originally. I started my career in automotive, came to GE in GE Aviation in the year 2000. A lot of my experience was designing and developing parts and manufacturing processes in the pictures you see on the left. 30-stage progressive stamp dies, forging processes, casting processes that really just limited the design freedom that we had, and we had to follow certain rules or things didn't work. So I started to use additive very roughly way back in 1994, 1995, a little bit in university, and then in the automotive, started printing things like little FDM printers that were, nice. They made cute little toys that we could put on our desks and think about different design options, but fundamentally it didn't change the way that we thought or worked. In the 2000s, I started printing parts to get them more quickly within GE Aviation. So we run a lot of technology demonstration engines. In some cases, the capability to print a part and get it just quicker was advantageous. But again, it didn't really change the way that we fundamentally approached our products. As we transitioned to the early 2010s, they call it 2011, one of the things that we started to see was that we could truly start to differentiate our products through the use of 3D printing or additive. So I took over a team that was focused on a production tooling application for our jet engines early in 2011. Our original process for that application, we had 2 machines. They were stored in a closet in a facility that when you open the door to the closet, the first day on the job, I went to tour the facility. I opened the door, I hit the printer, and I scrapped an entire build of parts. So welcome to the team. Nice job, Chris. So that was my start in sort of production additive. We've come a long way since then. In 2012, 2013, our teams really started to think about how to productionize the LEAP fuel nozzle. And I won't go into details on the LEAP fuel nozzle. We talk about it way too much, and I don't want to talk about it here. But fundamentally, it helped us start to approach additive in a different way than we had in the past. As we transitioned into this, we started to discover, the good news was we had a really strong champion at sort of our senior leadership level who said, we're going to go 3D print this fuel nozzle because it makes sense. So the business case was already decided, and we just started doing it. As we worked through that process, we learned a lot. We fell down a lot. We did things wrong, we screwed things up. We did some things right. Ultimately, we were able to productionize that process and create and certify the LEAP fuel nozzle. But what we also discovered was, as we looked beyond the LEAP fuel nozzle to what's our next application in GE Aviation, what's our next application across our other businesses, we struggled in some cases, to find how do we get through that adoption curve. And so some of the themes that we saw, and this is a very brief summary, like, which parts make sense? Where do I even start? And I know a lot of you, having the fact that you're sitting in this room, you're probably a little bit farther along than just thinking about where do I start. But as a data point, within the last day and a half, I had 10 people walk through our booth and actually asked me the question like, hey, I didn't know you could 3D print metal. And I was shocked. I was like, what? You don't know that? So for me, I think those of us who are, I would say, additive evangelists or whatever you want to call us, I think we think the rest of the world is a lot farther along than they are. One of the things I hear a lot from customers too is, design engineers by nature want to go create really cool geometries, really exotic performance, etc. But often engineers lose the line of sight from, okay, it's really cool, to what does it mean in terms of a business case outcome for my company at the C-suite level. We had that same problem in GE Aviation, right? We invested a lot of money to go do the LEAP fuel nozzle, And then the next applications, we said, oh, well, these are all easy. We just go do them, and our management will buy in. Well, our management said, well, whoa, like, this has to make financial sense. It's not just because it's cool. So, building that business case is important. Part of that, of course, is financial constraints. In many businesses, there's different pools of money for R&D versus equipment versus, ultimate product, shipping a product. And then another one that we discovered was, we started with a very small team to do the fuel nozzle and some of our other additive products. In 2011, we had maybe 10 to 15 engineers who actually understood the process and knew what to do. Today, I'm not part of GE Aviation exactly anymore. I'm part of GE Additive. But if you look at those 10 to 15 engineers back in 2011, today we're at 600 plus within GE Aviation alone, and then several hundred more within GE Additive. So we've really been able to grow that capability, but I hear it a lot from customers and internal to GE and other businesses is, I only have 2 people who can do this, but I want to go do 10 parts this year. One quote that I love that I hear from a lot of customers is, hey, good news, my boss told me I have money to spend on additive this year. I don't know what to do, right? So these are some of the things that we've heard inside of additive, and as we walk through or inside of GE, excuse me, and as we walk through this, we've started to develop the thought around how can we help conquer some of those adoption barriers. So one great example within GE was, this is an aviation product, but early on, this engine was fully designed as a conventional product. It was in early stages, initially all designed as sort of traditional manufacturing, traditional approach to the product, and a traditional approach in terms of the time to get the product to market. The customer came back to us and said, it's not fast enough. I need it in 3 years instead of 4. It's not fuel efficient enough. I need better fuel economy. The CG isn't right. The weight isn't right, et cetera, et cetera. So we took that on ourselves to say, we're going to go redesign this product with additive in mind from the beginning. And you can see the stats on the screen, right? So compared to our competition, 20% lower fuel burn. If you don't work in the aerospace environment, that's a huge deal. 5% in weight reduction, again, that's a big number. The entire engine weighs about 500 pounds, so quite a bit of weight that got taken out. The big number on this chart that I think really boggled my mind when I first saw it, because as you're going through the process, you don't think about it. What would have been conventionally 855 parts, now 3D printed as 12 assemblies. So think about logistics, think about drawings, think about sourcing, think about all the things that you have to do to go procure 855 parts. Now you have 12 that you're making yourself or your supplier's making for you. Massive simplification. As a data point, this engine from an assembly standpoint goes together about twice as fast as our conventional counterpart. About 25% of this engine is additive, and no structural castings whatsoever. So when you think about that 4 years down to 3 years, long lead time part is a casting in our world. Taking that down from 4 to 3 was a big deal. So I want to talk a little bit about a specific example, and this is really just to demonstrate some of the thought process, right? So this is the C-sump housing. This is part of the aft bearing support of the engine, if you're not familiar with jet engines. It provides the lubrication, supply, scavenge, and ventilation system to the bearing compartment. When we started to design this originally, it wanted to be 75 parts that got fabricated together to create a C-sump. There were two forgings, 2 castings, I think it was 22 machining operations, about 20 bolts. We liquid nitrogen. We would have to liquid nitrogen cool part of the assembly and induction heat the other part of the assembly to fit it together to keep the tolerances. Now when I change that thought process and I 3D print it, I actually improve the tolerances, I remove that assembly step, I start to just change the way that the whole engine goes together, and I remove opportunities for human error. So as we walk through this, 40% assembly time reduction, it's not just that assembly time reduction, but it was also the capability to eliminate the errors. 60% lower costs, ultimately 75, what would have been traditionally 75 parts fabricated now in one 3D printed assembly, and ultimately 20% lighter. So just a glimpse of one part that went into this engine, but a big difference, a big differentiator within GE Aviation specifically. So this was great. This is a GE Aviation example. You know, we're very proud of that, but you know, we saw that we needed to go. We were just in the process of launching GE Additive, and we said, you know, now that we're launching GE Additive, how do we start to replicate this in other areas of GE as well as in outside companies? So when you looked at GE as we formed GE Additive, we had, you know, we brought into that, fortunately, a very strong heritage of 3D printing, some of which I just described to you. You know, we had over 400 patents around additive. We had 40,000 production parts that we had 3D printed and were in production in the field. But frankly, most of that was in aviation. Some of that was in power, some in oil and gas, a little bit in healthcare, but we weren't sure that all of that would spread across all of GE. So we formed a small team that we sent out to all those other businesses. We started to train engineers. We started to gather their ideas. Really, the way that we decided to do that was because we said if we can't prove it to ourselves that our product will work and that our approach will work in our own business, how are we going to sell it to the public? So we took about those engineers, we sent them out at the beginning of 2017. Long story short, we developed over 100 production applications that are either in production now or destined for production within GE across all of our business units. We have line of sight now to $3 to $5 billion of cost out over the next now 9 years by 2026. And that's in every business unit. And it's not just necessarily piece part cost savings, but that's logistics cost, tooling cost, inventory cost, lots of cost benefits across our product lines. So this was great. And, you know, hey, good news is we proved to ourselves that we could go leverage our capability that a lot of us had learned inside of aviation, and we combined with some of our other GE team members. We hired some people from the outside. We mixed all those folks up together, and the good news is we had a great outcome for GE. Mid last year, we said, well, okay, we've kind of proven to ourselves that at least we think it's feasible, that we can go have success in other industries, so let's go take a small team and go out to customers and start trying to help customers go from, you know, whether you're an advanced user of additive or you're just starting an additive, how do we help those customers go faster? So, oops, excuse me, I think I went forward. Can you go back one chart? I'm sorry. Okay. I think somehow the charts are out of order, but one example, maybe just to highlight real quickly, this healthcare, this was an example from our healthcare business. So this is an anesthesia manifold that mixes a lot of gases together. You know, traditionally it's honed out of a block of aluminum. It's assembled to many different parts. It's limited by tool path drilling opportunities. You know, we took a look at this and said, and oh, by the way, it wasn't very serviceable. So we took a look at this and said, you know, we can redesign this to simplify it. About 75% less material, which was a key CTQ for our healthcare business, which was they wanted that anesthesia manifold cart to be lighter. So they wanted to reduce the weight. But the big thing here was we actually opened up space where now they could service the unit. There were some sensors in the unit that traditionally they had to disassemble the entire unit to get to. This enabled us to open those up. So this is a simple example that we did within our healthcare team, but really just kind of demonstrating the power of what additive can bring. So sorry, I got confused there. This was the chart that I thought was next. So as we started to look at this and think through what do we actually do when we go and talk to customers, and in this case it was GE internal customers, but as we started to talk to external customers, we heard a lot of the same thing, right? I have a 3D printer, I'm making prototype parts, but I really don't know what my success story is going to be. I'm making some parts every day, or even companies that have, you know, I have 10 printers, but I'm not happy with the productivity or the profitability of that solution. So we looked at this and said, you know, we really need to help lay out and help customers accelerate their journey through this process. If you can define the business case up front and get your leadership bought in from the beginning, obviously you need the skill set to design for additive, whether that's software, analysis, build simulation, topology optimization. You have to have some of that capability. Ultimately, everyone will need to make a part, or will need to have someone make a part for them. A big jump, though, is, okay, some people can get to that stage, but then taking that and industrializing that to, I don't just have one machine, or I don't have 3 machines, I have 20 machines, 50 machines, 100 machines, and I'm 3D printing the same thing with the same material quality every day. And then ultimately, in several of the industries that maybe you all work in, right, aerospace, medical, for examples, there's a heavy regulatory burden there that if I don't go to the regulatory agency with the right data and provide them with that data, I don't succeed. So this was our view of, just how did we go from, starting a project to a production solution. We went through this journey ourselves, and we thought, as we started to talk to customers, we heard from them a lot of the same challenges. So we started a team we called AddWorks. We started small. Now we roughly, we've scaled up that team. So what is AddWorks? So AddWorks is a consulting service that provides designers, engineers, and material specialists to help customers really adopt additive more quickly. So in order for us to be successful, we need you to be successful, and AddWorks' whole goal is taking you from point A to B as quickly as possible. So part of that, one of the things we like to talk about is upfront is something we call a discovery workshop, which is just, let's sit down, let's talk about your product line, and let's just help you from the beginning, as an example, find a part that will make business sense for you. So if you look at, why do we think that GE provides in our AddWorks team, a benefit to our customers? So we have within that team over 150 specialists who have been designing in places like aerospace, energy, automotive. They've been designing. We have material expertise, and we have what we call industrialization or process expertise to take those products from, okay, great, I've printed one, to now I'm printing thousands or tens of thousands a year. We've completed over 200 plus projects with our customers, both internal and external. So, and that's across many different industries. And I'd never thought in my life I'd be talking to a meat processing customer, a nuclear customer, and an automotive customer in the same day, but that's some of the scope of things that we've talked about. One of the benefits of being part of GE is we have a huge network of material scientists. So we have our global research center that provides us a lot of depth in materials, and we really leverage that within our additive team to help customers identify and qualify the right materials. Part of coming from GE Aviation, obviously, we have the FAA additive certification experience that allows us to help guide customers through that process. Similarly, we have some experience with the FDA as well. Part of our offering as well is to have customer centers where, customers who aren't as familiar, you can go to Munich, you can go to Pittsburgh. Those are our 2 centers that we have so far. You can see a machine. You can even help, we can help you look at what your process should be. We can make you a few parts if you want. And ultimately, our goal is to get you into a supplier or get you into a successful business outcome of you printing your own parts. So one thing I'd like to offer to all of you, if you're interested, we have some upcoming events. Part of my role within GE Aviation over the last 7-8 years prior to coming into GE Additive was what I call evangelization. Really trying to spread the word about additive, right? What is additive? How can we help? Obviously, shows like Rapid are a great place for people to learn. But we're also providing some free sessions coming up. Salt Lake City on May 1st, Knoxville on May 24th, hosted at Oak Ridge National Labs, and then in LA at the beginning of June. So if you are interested in that, please email Joyce Young from our team. those events are really meant to be, if you're an additive expert, you're not going to want to go to this event. It's in full transparency, right? If you're an additive expert and you want some help, please contact us. So in closing, what I'd like to ask you is, if you're interested, please stop by our booth. So we're at booth 1318, kind of in the center of the hall behind us. Visit our website, geadditive.com. There's some information there, some of the same information you saw here, but you can get more details on our actual product offerings, or you can call your local salesperson. From my perspective, if I sum up all of AddWorks into one sentence for you, it's helping customers accelerate their additive journey. So thank you for your time. I appreciate your attention.
Thanks, Chris. So, questions for Chris? Come on, we got to have questions. Who's got questions? Right here.
Hi, thank you for your talk. I was wondering, does AddWorks also help develop part on Atlas? And what is the maximum size part can you do?
So if you don't know, folks in the crowd, what Atlas is, so the question was, does AddWorks help develop parts on Atlas? So Atlas is our large laser metal additive system. We introduced that at Forum Next back in November. It's currently in beta phase, so we're testing that inside of GE today. That machine is 1.1 meter by 1.1 meter by 300 centimeters tall. So you can make quite large. You can imagine what GE Aviation, as an example, may want to make in that type of a machine. So the short answer is yes, we can help develop and ultimately print parts on Atlas. Right now our capacity is fairly low, so we're doing that with a few key customers. As we transition into 2019, we'll be able to do it for more and more.
Who else? Other questions? Questions?
Just one in the back there.
He made the mistake of giving me the microphone. Specifically with the catalyst engine that you mentioned, what was the trade-off with the maintenance costs for the additive parts versus the traditional manufactured components?
You're talking field maintenance of the engine?
Yes.
So it's a good question. So, that if you look at that part consolidation that I talked about, the 855 parts to 12, there are parts where we thought about combining them that we intentionally did not combine them because we know that they were sort of typical serviceable items, right? That hot gas path parts typically are more often serviced. So we intentionally didn't combine some of those parts together and left those as separated parts. One of the things that we benefit from with additive is the fact that now we have shape freedom that we've never had before, and we've eliminated things like braze joints, weld joints, stress concentrations that cause field maintenance issues. So we have a part, and I can't go into gory detail about it, but we redesigned it with additive. We went through and looked at all of the failure modes of that part in the field traditionally. 98% of those 98% of those failures were attributed to conventional manufacturing. So the ability to eliminate stress concentrations, weld KTs, braze KTs, helps us really, benefit actually on the maintenance side. So, but there is a conscious choice there of, we joke sometimes that a jet engine ultimately wants to be two parts, a stator and a rotor, but it's not quite that easy.
On the other side.
Can you elaborate a little on the business model for AddWorks? Because I'm not clear, is it a business development front end for machine sales? Is it a standalone consultancy? How do you engage with customers? Because ultimately the outcome may not be a GE machine. So just explain a little bit how it works.
Yeah, sure. So it's ultimately a consulting service. Obvious, if you're just want a consulting service, we can help with that. If you're ultimately going to buy our machines, or you're going to work with a company that we work with that buys our machines, you're going to get a lot better price on that consulting service. So it's a little bit of both, but ultimately it is a standalone consulting service that will provide all of the things that I talked about. There's a question here up front.
I had a question over here. as far as going through the conceptual to end product, how many software packages did you go through to get there?
Great question. Are you talking on a single part or over the last several years?
I would say probably just your most recent production parts.
So, I mean, roughly speaking, probably 3 or 4, most recent. To be frank, we've tried almost every software out there, and we've had successes and failures with all of them. In some cases, we've written our own code on top of them or adjacent to them to enable us to be successful. So today it's 3 or 4, depending on the part.
Thank you.
Sure.
I have a question here. So
yes.
In aerospace, fatigue properties of materials are very important. Traditionally, they have been understood very well for wrought materials. What work has GE done to understand the fatigue properties of additive manufactured materials?
Good question. So, I mean, to go back to the LEAP fuel nozzle as an example, right? I mean, the fuel nozzle is in a very sensitive LCF environment, right? You have very cold fuel next to hot gas path air, and then you have combustion on the back end. So, heavy thermal gradient, challenging environment. So, part of our job, really, or our safety task with the FAA was we had to prove to them, are we able to make the right material properties, LCF, HCF, et cetera. So we went through a lot of material characterization. Some of the pitfalls that I talked about of doing it wrong the first time, we did some of those wrong the first time, but we learned over time how to do it right. And this most recent catalyst engine, the aviation team, it took 3 years to do the fuel nozzle in terms of characterization. We did 5 materials in multiple different machines and 12 parts in less than 18 months. So.
Hi, you mentioned discovery workshops.
Yeah. Hey, Brian.
How do they work? What is involved in those?
So really, it's just an initial engagement with our customers. It's a small, relatively low price type of workshop that we have with our customers to say, let's get together for 3 to 4 days, depending on the customer's desires, really. And it's scoping out their product line, looking for the best opportunities in their products, and ultimately getting them to, our goal is to find the best application for them as quickly as possible through those discovery workshops.
Hi, Chris. Our question is, from your speech, we see a lot of work around the metal parts. So how do you see the plastics?
So good question. So, I mean, today GE doesn't offer any polymer machine or material or anything. We are a heavy user of polymer additive in our businesses. So we do use polymer in many places in our businesses, from everything from simple tooling to, production applications. So we're a heavy user, and we know a lot about materials and machines and the process, but we don't sell that as a product in terms of machines or materials today.
What kind of non-destructive inspection do you usually do on parts, like for your jet engine you were talking about?
Sorry, I'm lost where you are in the room. Oh, thank you. What non-destructive inspection do we do?
Yes.
So it varies depending on the part, but I mean, typical, in some cases you do some basic CMM. We typically do CT inspection, and if you're interested in CT, we have in our booth, we have our inspection technologies team is there with one of our small CT machines as a demonstrator. So typically CMM, CT, and then there's some destructive testing on things like test bars as well as part of that process.
Thank you.
Sure.
Other questions? Anybody else? Anybody? All right, well, let's hear it for Chris Schuppe, AddWorks leader, GE Additive, for a terrific presentation. Thanks.
Thank you.